Guys, good evening. I hope I'm pretty much audible as well as visible. I'm just starting the session, guys. Give me a minute. Hello, Shubham. So just a minute. I'm just starting it actually. Cool. So wonderful, guys. So with this, I think we can get started. So today we are going to prominently talk about the deep learning part, guys. Okay. So we have been discussing about all the fancy terms and how we can use them in some or the other way. So I'm going to give you today an introduction to deep learning. And in fact, towards the end, I'm going to give you the little surprise. So please stay tuned till the end of the class. And I'm going to give you a little surprise tonight, in today's session. And I'll be showing you how exactly you will be proceeding for your next steps. So we have been discussing a lot of the concepts. I have introduced multiple concepts to you, but if you would have realized, so we haven't been talking much in detail about these concepts, right? So we have been covering from a definition perspective, like a workaround of few things. But now, since now we have been discussing about all these things, so it's a high time that we get into the technical details of all these concepts. So for that, you have a little surprise towards the end of the session. So please stay tuned. So I'll be showing you what and how will be our next steps. Okay. Yes, Shubham. So हम डिटेल में बात करेंगे like what all things would be covered henceforth and where exactly, what platform. So as I've said, please stay tuned. I'll be disclosing all the details towards the end of our class. Okay. So, but in prior to that, I'll be quickly demonstrating what is deep learning. So, giving you a fair understanding what is deep learning. In fact, we have already. Okay, so what is deep learning for us? So basically, we understood that deep learning is nothing but another what to say subdivision of machine learning, and machine learning comes under artificial intelligence. So we have been discussing around the keywords, but today I'll give you a descriptor towards deep learning and what all different concepts are there and how do we use it. So we'll be talking about all of that today. So let's get started. Just a minute. So today we will be talking about deep learning, as you know. So, but before that, just gonna quick introduction about myself. You know, my name is Arpit Jain, and the only reason I'm here with you because data science is my true passion, and I really like sharing my expertise with people. Technical front, I have around 10 years of industrial experience in analytics, and currently working as a lead data scientist. And along with that, I am also a motivational speaker. I do talk to students regarding placements, career, jobs. So anything in general also, please feel free to reach out in the chat. It's pretty much a live session. So we can talk on any front. Okay. So please do put up your questions. I am monitoring the chat. Okay. Cool. So agenda for the day, as I've told, so we are going to prominently talk about my deep learning side. So we will be understanding what exactly deep learning is. So deep learning, as you know, it's basically a subdivision of machine learning itself. So machine learning has a further subdivision called as deep learning. So what is there in deep learning so that it is actually getting identified as a separate entity together? But since it falls under the same umbrella of machine learning, so my core objective still remains the same, guys. What is my core objective? to understand the pattern, to understand pattern, and then to understand the pattern, post that, identify the trends, and then based on this, predict trend for future. So that's basically what machine learning does, right? So we have the core objective of any machine learning method or the algorithm or the rule is to identify the hidden patterns available in my data set, and based on that trend or the patterns which has been identified, I am intended to predict the similar values in future. So that's what pretty much machine learning does. So now on top of this, we are talking about machine learning where deep learning comes into picture. So deep learning is another subsection of machine learning where again the core objective remains the same, but the process of it, the way of learning, the methodology behind the learning process for a machine changes. That's where a separate concept of neural networks comes into picture. So we're going to talk about layers formation on which the training happens. The training, basically this learning process, this understanding of pattern, that is going to happen with something called as layered structure. So we're going to have a network or a layered structure where multiple different things will be combined together in different layers of information, and that's how the learning will be happening. So we'll talk about that in detail, and that is where deep learning comes into picture. So we'll quickly understand what is deep learning, how this works. So we're going to talk about first what is deep learning. We're going to talk about how it works, so the working principle behind that, and then we're going to talk about few of the applications or the examples basically where deep learning can be used. Okay, so the field where deep learning can be used. So let's get started. So very first thing, let's try to understand what is deep learning, guys. So deep learning is a type of machine learning. Can you see this? It's a type of machine learning and artificial intelligence that imitates the way human gain certain types of knowledge. So as I was explaining, ultimately, when I'm talking about artificial intelligence or when I'm talking about machine learning, the end objective ultimately is to imitate or replicate what a human brain does, right? And since we know that machine learning is pretty much falling under the category of weak AI or narrow AI, that's where I am only going to solve one objective at a time, right? If I'm solving one objective, that means that I'm going to look at one problem statement which is supposed to be solved here, right? So that is where I'm going to say that deep learning comes into picture, and I'm going to imitate the human brain, the knowledge behind that, so that that problem statement can be solved. Obviously, then deep learning be a part of it. So if we talk about the bigger umbrella, so we have artificial intelligence here. Inside artificial intelligence, we talked about we have machine learning, and inside machine learning, we have deep learning. That's how we bifurcate our three different parts of data science. So artificial intelligence, under artificial intelligence, machine learning is one part of artificial intelligence. Then it comes deep learning, right? So always keep that in mind, guys. So this hierarchy is very important. So never think that deep learning is a completely separate topic when considered about machine learning as well. So there's a deep learning is a subtype of machine learning, basically. So at its simplest level, deep learning is nothing but where we're going to say it can be thought of as a way to automate the predictive analytics. Simple. I'm going to talking about a method which is used to automate the predictive analytics. So my end objective is still the same, right? I'm still talking about how I am going to predict the future based on what patterns I have. So that is still my end goal. Obviously, my problem statement would be changing likewise. So we will be discussing about those problem statement as well. So at the simplest level, deep learning can still be thought as a way to automate my predictive analytics methodology. So while traditional machine learning algorithms are linear, deep learning algorithms are stacked in a hierarchy of increasing complexity and abstraction. So machine learning methods are generally linear. By that, I mean, we are talking about optimization strategy where the end objective is to minimize the loss or from the cost function, basically getting the minimum error wherever I have in the linear methodology and ultimately getting the results. But in deep learning, we are calling about layers, the stacked methodology, as I was talking about, where it depends on adding up the complexity and abstraction on every passing layer of the networks which you are going to build up. And all of these stacked layers is where I'm going to have the learning process done. Okay, so traditional machine learning are linear, where in this case, it is pretty much stacked with multiple layers of network architecture. That's what we're going to talk about in deep learning. Okay. So how exactly it works? So what is the methodology behind this? So computer programs that use deep learning go through much the same process as the toddler learning to identify the dog. So what happens here is, let's consider it as a very simple example. So any toddler who is trying to learn something new, we can actually compare it with the similar program in the computer which is trying to learn the similar kind of a process, right? Then each algorithm in the hierarchy applies a non-linear transformation to its input and uses what it learns to create a statistical model as output. And obviously the iteration will continue until the output has reached the acceptable level of accuracy. So what it means, technically, if I have to draw this out, so what happens, I have, say, certain input features. This all gets passed to, again, certain layers, and then this converges to certain another layers, and finally this again goes to multiple different layers, and I have final output here like this. So I have my input layer here, I have my output here, and whatever I am doing this inside, these are called as my layers. That is where all of these connections here is basically a weight, W1, W2, W3. And each of these I'll call as hidden layers. We are calling this as hidden layers. So technically in the neural networks, it's pretty much a black box technique where the learning of this internal layers is pretty much hidden. We have an optimization strategy as well. And each of these individual blocks gets actually adjusted on their weights. There's a method of bias. There's a method of, again, the back propagation. There's a separate concept behind that. So what it does, it adjusts the weight of all of these different connecting layers between my 2 points from left to right. And that is how the concept of adjusting the weights and identifying the right set of parameters for layers on each of these neural networks comes into picture, right? So what happens is, for every iteration, it keeps on iterating the weights. It keeps on factors, and with time, with iteration, it keeps on changing these weights so that ultimately at the end the optimization reaches its maximum level of accuracy, where the errors and the the discords are minimum, right? So technically, for now, you can just keep this in mind that in terms of building up the layers, there are two things which we have to keep in mind. First, obviously the layers, input output layers, and in between we have the hidden layers. On top of these, the layers which we have built up, we have to adjust the weights of each of these connectors. So what are these connectors? These lines which you can see here. So all of these lines, right? So these are my weights technically. Okay, so the connectors between my first layer and the second layer, second to third, third to fourth, fourth to output. So all of these is pretty much my connector, right? And the learning is basically the process of adjusting the weights of these connectors between multiple different layers, so that from input to output we reach the maximum accuracy, level of accuracy, by reducing the error. So minimum error, maximum accuracy, that's basically what we are going to look at. Okay, that's basically how it works with multiple iterations. So in the learning method, there are certain important keywords. So we are going to discuss about them one by one. So first is my learning rate decay. So the learning rate is basically one of the hyperparameter, a factor that defines the system or set conditions for its operations prior to the learning process, that controls how much change the model experience in response to the estimated error every time the model weights are altered. So basically what it means, every time when we change the weights, so because as I've said, in the iteration process, we always start with a random weight, any random weight. Now for the next iteration, we have to adjust this weight to something else to recalculate my error, right? So what is that change of rate? When I say that I have started with 100, now in the second iteration, I have to go to 110. So there's a difference of 10. So what identifies this? Who governs this difference? Whether I have to go to 110 or 120 or 130. So for 110, the difference is 10. For 20, it's 20. For 130, the difference is 30. So that difference, the rate of change of my weights, which I'm doing in every iteration, and based on which I'm going to estimate the error every time the model weights are getting adjusted, that is where the learning rate comes into picture, right? So learning rates that are too high may result in unstable training process or the learning rate of suboptimal set of weights. Obviously, if my learning rate is too high, when suppose I am 100, now the next iteration I'm going to put at 150, and the next I'm going to put at say 200. So I have a gap of 50, which is too much. Rather 100, I should try with 105, maybe which is much closer. So I do not lose out on the absolute change of patterns when the learning rate changes, right? So it is always advisable that we keep these step size or the learning rate smaller, right? So it is always advisable that we do not increase the learning rates too much, and the learning rates that are too small also may produce a lengthy training process, right? And it has potential to get stuck as well. So obviously, if I'm keeping the learning rate as too small, so many iterations will be there. So going from 100 to 200, I'll have to perform maybe 1,000 experiments, right? So I have to take a trade-off where it is not too low or not too high. So smartly, we try to understand what could be the learning rate for a particular problem statement. Again, it definitely varies from one problem statement to another, and there is no fixed rule, again, to be honest, guys. So always understand, in data science, whatever we talk, it's more from a theoretical perspective, right? So but I can not say that this is the exact value for your own problem statement. I can only say how it is used, but exactly when you apply this, so you have to keep your eyes and ears open and understand for your own business problem what makes more logical sense. Okay, so that's basically what learning rate is. Second, we call about is transfer learning. So transfer learning, again, interesting way in which the learning process happens. So this process involves perfecting a previously trained model. So it requires an interface to the internals of a pre-existing network. So first, users feed the existing network new data containing the previously unknown classifications, and once adjustments are made to the network, new tasks can be performed with more specific categorizing abilities. So basically what happens in this case is we are utilizing a pre-trained model for our use case. I'll give you a very practical example. Suppose I'm trying to make a model to classify the image of different animals. So that's basically what my objective is. I'm trying to create a model which will help identifying the different animals based on their images. So image classification problem, right? So right now, suppose the database which I have, it says the images of elephant and a rhinoceros. I want to distinguish between the images of elephants and the rhinoceros. Okay. That is definitely, I can start fresh and then I can start making a new model. That is absolutely correct. But imagine I already have a pre-existing model for 10 other animals. So dog, cat, snake, lizard, rat, say 10 different animals, not elephants and rhinoceros, but some other 10 animals. So what we can do in transfer learning is we can use this information as well. So the pre-trained 10 model for 10 animals. And on top of that, we can introduce the newer data set, which is for rhinoceros and elephants. And combined, we can make a stronger model, which will be able to classify not only previously trained 10 animals, but also the newly trained 2 more animals. So the output will have 12 different classes. That is again very good way of using the previously trained models. So that is called as transfer learning. And this method has the advantage of requiring much less data than others, thus reducing the computational time. So what we do is, since we are already training the utilizing the previously trained data, so we might not need more and more data, because deep learning methods are always data hungry. The more data we feed in, the better the results would be. Okay, so obviously in this case, transfer learning does not require much data compared to the normal learning method. So we're going to use the previously trained model for the methodology, and again some advancements on the data which we have right now. It will make better models. So again, transfer learnings are very standard mechanisms in this case. Also training from scratch. So in this case, I'm going to develop everything from scratch. So this method definitely requires the developer to collect a large labeled data set and configure a network architecture, then learn features in the models. So 2 things here. So when I talk about the deep learning methods, I am supposed to collect large labeled data. So when I'm talking about classification of elephants and rhinoceros, suppose if I have say 200 images, that is not an ideal way. I might look for 1,000 more, maybe 10,000 more. More the data, more the samples, more the labeled information, better the model performance would be. That's how problematic it is, and that's how data hungry these deep learning methods are. And obviously, even after having the data, I have to customize the layers of my neural networks manually. Obviously, we will have to put some experiments there, but we will be configuring the network architecture that can eventually learn the features and eventually the model for our training purpose. And this technique is specifically useful for new applications as well as application with large number of output categories. So however, overall, it is a less common approach as it requires large amounts of data and causing training to take days or even weeks. So generally, we normally don't use training from scratch in a practical application. So we normally use transfer learning, right, in terms of deep learning methodologies, and then eventually going to use the set of information which we already have, and on top of that, the additional informations, like the way we're going to add few more data points and then the requirements accordingly, and then use the similar models which is already in place. But training from scratch can also be done. Okay, so transfer learning, training from scratch. And then we also talk about dropout. So this method attempts to solve the problem of overfitting in the network with large amounts of parameters by randomly dropping units and their connections from the neural networks during training. It has been proven that the dropout method can improve the performance of neural networks on supervised learning tasks in such as speech recognition, document classification, computational biology, etc. So dropout is again one of the core concept of deep learning neural network layers. So basically what happens, as I was talking about building different layers, right? So all the parameters from one layer gets transferred to the second layer from left to right direction, correct? In dropout layers, what we do is we try to remove, we try to drop out certain random values of these layers when the transfer happens from one layer to another. Suppose I have, say, 100 parameters on layer 1. The moment these 100 parameters gets passed to the second layer, layer 2, I put a dropout of 0.2, say 20% dropout rate. So out of 100, randomly 20 points will be dropped out, deleted, as simple as that, and only 80 will be given to the next layer. That's very normal. Can you hear me, guys? I think there was some problem. Okay, so what I was saying is the dropout layers. So ultimately, randomly few points will be dropped out from my layers. Again, one of the very crude mechanism of deep learning layers, guys. So now quickly, let's try to understand few applications of my important parts, how deep learning and where exactly we're gonna use deep learning. So first is customer experience, CX. So deep learning models are already being used for chatbots. So automated chatbots, we have been using chatbots in multiple different platforms, right? So automated responses. So another crude application of deep learning, and as it continues to mature, deep learning is expected to be implemented in various business to improve my CX and increase customer satisfaction. Definitely, lot many ways, chatbots and auto helpers and auto detect troubleshooting mechanisms. All of this is pretty much where deep learning is prominently getting used, guys. Next is text generation. Machines are being taught for, Grammarly, you have seen this application. Likewise, lot many things are there, which is for auto correct of your grammars, right? Auto fill up, auto suggestions. So you might be seeing in your day-to-day life also on your phone, right? So text matching, all of this is pretty much part where deep learning comes into picture. So NLPs, natural language processing, text generations, all of this is pretty much where text comes into picture. So again, pretty much part of deep learning, guys. Aerospace and military. So deep learning also being used to detect objects from satellites that identify the areas of interest as well as safe and unsafe zones for troops. So definitely we're using a lot of aerospace satellite imaging. So there's a separate field, we call this as for space satellite imaging, where we are actually viewing the satellite images and classifying this lot many different things. So safe regions, unsafe regions, area of interest. So a lot of imaging happening from the satellite images. So it finds it's tremendous use in aerospace and the military purposes as well. Industrial automation. So we're talking about improvement of my worker safety in factories and warehouses, automatically detecting wherever the person is going too close to a machine. So like real-time object detection, right? So if the worker is going too close to a working machine, automatically alarm getting coming up, right? So object real-time object detection, or unwanted motion detection, right? Suppose an animal comes, maybe a cat or a pet dog, something like that, and it goes too close to a machine, right? So there's a hazard there. So again, raising an alarm in the real time. So real time detection of an object, moving object, motion detection. Again, industrial automation, pretty much where it takes its importance. Medical research. So cancer researchers have started implementing deep learning into their practice to detect the cancer cells. Very, very, very interesting. And not only cancer, in fact, guys, multiple different diseases. Again, we know that CT imaging and the brain scans, lot many different things where it finds its uses, because we talk about identifying the images. Now we're not talking about Excel files or CSV files. We're talking about unstructured data like text, images, videos, right? Audios. So all of these is where it finds its usage. Next is computer vision. Deep learning has greatly enhanced computer vision, so providing computers with extreme accuracy for object detection, image classification, restoration of my old image, segmentation, all these fancy places where definitely deep learning finds its usage. And not only limited to this, there are a lot of other applications as well, which we will be identifying with time. So technically, this is what I wanted to cover today. But now, since we have come to an end to of our class, I want to show you something which is very, very, very interesting. Okay, so this is where I'm going to talk about now what next, right? So interestingly, guys, GFG has come up with a boot camp which is completely free of cost. So you're not supposed to pay anything. So going forward, we will be meeting on bootcamp live on GFG. Let me show you on the screen also where you can register yourself for that program. So make sure that you register yourself to bootcamp GFG live. So I'll be showing you the syllabus. We will be going in detail there. So we will be covering those topic subjects in detail. And for that, you are not supposed to pay anything. Like the way we are having a free session here on YouTube, we will be going detail on GFG channel now for the program. Okay, cool guys. Let me quickly show it to you from where you can register yourself. Just give me a minute. Let me know, guys, if my screen is visible to everybody. Can you see the GFG homepage? Give me a thumbs up or yes in the chat if everybody can see this GFG homepage. Yes. So now on here in this page, you can go to this courses section. This is my homepage actually. So practice.gfg geeksforgeeks.org. I'm going to go to courses. Under courses, if you scroll down, you will see something called as Upskill here. Okay. Click on Upskill and you will be seeing a course called as Data Science Bootcamp. Can you see this? Data Science Bootcamp, and it is for completely free. So you have to go here, click on this Data Science Bootcamp, and you can register yourself here. If you click on this register now, you can fill up your details, and definitely you can go here and try to see what all things you want. Let me quickly tell you what all different topics we will be covering here. You can see this is the entire syllabus we will be covering. So we will be talking about data analysis with Python in detail. We will be covering multiple different types of data sets. So we will be actually doing the real analysis live. We also will be talking about web scraping. We also will be talking about dashboards and Tableau. We also will be talking about building the ML models from scratch. So we have been discussing about the ML models, but now we will go in detail about building the ML models. Interestingly, we'll also talk about NLPs, natural language processing, using the NLTK package and the Spacey package. So we'll go much more detailed in terms of applications of how you can build up your natural language processing models. Neural networks, as I was talking about, how to build up the layers. Just now we talked about the layers part, so we will go in pretty much detail. So TensorFlow, is an open source library provided by Google. So that is where we're going to use TensorFlow to build up my neural networks. We are also going to work with images. OpenCV is the package from where you can pretty much use the processing of my images. We'll talk about that, and computer vision with CNN, convolutional neural networks. We will go pretty much in detail here. So you can imagine, so you're going to take out all of these things in detail, because now we have been already discussing about these concepts theoretically. Now we will go much more detail in terms of practical applications of it. And in fact, you can see the detailed course content as well. So the Python, looping, functions, strings, data structures, files, OS. Also, we'll talk about mastering NumPy arrays, and then we're going to talk about getting data analysis with Python, statistics, pre-processing, data analysis, and then we're going to talk about Tableau. We're going to start with the details of my Tableau, basic plots, fundamentals, designing of my plots, dashboarding. We also talk about web scraping, how we can use web scraping to identify my data. We're going to start with AI, machine learning. We're going to cover all these algorithms in detail: linear regression, multiple linear regression, polynomial, support vector machines, decision tree, random forest, some classification algorithms, clustering algorithms, feature engineering as well. Then deep learning, perceptrons, basically individual points, CNN, multi-layer perceptron architecture, image processing, pretty much in detail again. So all the imaging tasks, how we can build up our image model, natural language processing in this in detail. So all of this, you can pretty much get it for free, guys. So please register yourself, right? And then we will be having these classes live on Data Science Bootcamp program. Okay, and so here we are going to have the masterclass which is there. So now please, I would request you to register yourself, and we're gonna start from here. That's great. If you have already registered, Shubham, wonderful. So we will be actually doing this, and we will be moving from YouTube Live to Data Science Bootcamp. Okay, so we will go in detail about all these topics. Cool. Any concerns, any questions, guys? Any questions from anyone? LinkedIn. Let me check. I don't know why I am not getting a request. It might be somewhere down. एक मिनट रुको, मैं भी check कर लेता हूँ. I don't think you have sent it to right person, Shubham, because I am not seeing your request, to be honest. Shubham Sharma, okay, tech enthusiast, information technology student. Is this you? Yeah, I think I got you. Okay, yeah, I got your request. Cool, accepted, man. Cool, great. ठीक है, wonderful. So cool. I think I've accepted your request. So I mean, even if now I have, if you think that I'm not getting connected, please again ping me so we can talk about it. You can resend it, cancel it, resend it if it is not accepted. So I'll quickly check it. Cool, great, wonderful. So thank you so much, guys. So now we will meet on the bootcamp live sessions. Okay. So please do not miss to join the live sessions on bootcamp program. So we will be talking about things there. Cool. Wonderful, guys. Thank you so much. And can't connect what? 1 week. Let me check. Let me check. And there might be something internally from the IT thing. एक बार अपना पूरा नाम बताओगे? शुभम शर्मा. What am I supposed to search? Which, where do you work, or can you give me a few hints? Like, what should I search for on LinkedIn? I'll send it right away. I'm not able to find you actually. There's so many Shubham Sharma. अपने कॉलेज का नाम बताओ शुभम. सो आई थिंक आई कैन सर्च यू विद योर कॉलेज नेम. ऐसे तो डिफिकल्ट है ना. हाउ विल आई सर्च यू? Okay, I think difficult ऐसे ढूंढना. Let's do one thing. So the moment we connect on the live sessions, right? So we'll be discussing on Zoom there mostly. So I think you can unmute there and we can talk. So I think let's take it that time. Okay. Cool. Cool guys. Thank you so much. Let's connect on the live bootcamp sessions post on. Okay. And then we'll take it from there. Cool guys. Thank you so much. See you in the live session. Bye bye.